Since we don't have any robotic dolphins that we could be doing testing and training on, let's think through an example of doing reinforcement learning to try to teach a robot soccer player to score a goal. So this is supposed to be kind of a robot soccer pitch. This is the goal in blue, this is the ball in yellow, and this is the robot in black. And what we really want it to do is score in the goal. And that's worth 100. Again, just like in the dolphin case, it's very unlikely that the robot is going to spontaneously, drive around, hit the ball into the goal, experience the 100, and then say, okay, cool, that's what I'm supposed to be doing. So what are some things we could do shaping-wise? How can we modify this reward function so that it might encourage something in the direction of scoring the goal?
I think there are a couple of things one might do. I'll try not to overthink this. Well, in order to kick the ball, the circle with its circle feet has to get near the ball. So I could imagine putting some reward for being near the ball, wherever the ball is.
Cool. So you think like +1 is enough for that, or maybe?
I don't know, but let's start with +1.
All right. How do we define near the ball? There's going to be some kind of like epsilon ball around the ball.
Yeah, that makes sense. Or you could go all the way around and think about the distance you are to the ball is inversely proportional to the reward that you get.
Good point. All right, let's look at your way of thinking about it first. So if we're getting reward, the agent is getting reward by virtue of being close to the ball. What's a good policy? A good policy might be to just sit in place or sit a little bit closer to the ball and just rack up the points.
Sure. So then you would need something else, like hitting the ball is worth some points.
Aha. Okay, that seems plausible, right? So if the robot is getting additional points, additional pleasure for getting close to the ball and then actually hitting the ball, yay, that was really awesome. But of course, by hitting the ball, it pushes the ball away, which is going to cause the near to the ball score to go down. So it's going to actually kind of be sad that it did that.
Sure. But then you would want to give it something for getting the ball near to the goal. So just like being near the ball is worth something inversely proportional distance, you want the distance of the ball to the goal to also be inversely proportionally related to distance.
Yeah, that makes some sense. Right. So now we want to be careful that the amount of bonus that the robot gets for pushing the ball toward the goal is going to be an improvement over the fact that it's now no longer itself near the ball.
Right. So I don't know, 2 times or something. I don't know. I mean, I don't know exactly what the right numbers are, but there you go, something like that.
So it seems like we could play with these numbers for a long time trying to get the behavior that we want. And there are a couple really interesting failure modes. So for example, if we have like hitting the ball being defined as making contact between the player and the ball, and you get, let's say, +10 for that each time, ignoring these other factors for a moment, then one thing that you often see when you ask reinforcement learners to learn in that kind of setting is you'll see the robot walks over to the ball, touches the ball, gets its +10, and it turns out if you want to get that +10 again, the best thing to do is just back off from the ball a little bit and then make contact with it again. And in fact, really what you want to do is go up to the ball and just shiver, right? Just like vibrate back and forth, blah, 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 so that you just keep getting +10s over and over and over again. You can make a lot of money that way, a lot more than you could make by scoring the goal, because you can do this, 30 or 40 times a second if you're a good wiggler. And so this ends up actually, even though this additional shaping information that we're defining is giving good hints, it's also creating spurious optimal policies.
Right. Well, I mean, it makes sense, right? People have been making money for thousands of years by wiggling. So
I guess that's sort of true. But in this particular case, what we have to do is somehow make it so that you can't have a money pump. You can't do arbitrage. You can't, by doing the good thing, undoing it, and then doing it again, get double credit.
I see.
So a natural idea is to actually say, all right, so if you're going to get +10 for hitting the ball, then letting go of the ball should be a -10, right? You should not be able to make a profit by repeatedly bumping into the ball. Does that make some sense?
It does, but my favorite part about that is how you called it an actual idea, which I suppose makes what I said not an actual idea. But yeah, okay.
Oh, I did not mean to imply that or even
Yeah, it's fine.
say it.
It's fine. It's fine. It's fine. I see what kind of reward shaping you're doing. It's okay. In any case, what I guess is happening, so that makes sense. So you don't want to get into a place where you can get into a suboptimal positive loop. So you're going to say getting to the ball is good, getting away from the ball is not good. So you're going to learn to get to the ball and have to do something else that will get you even more reward, make it worthwhile backing away from the ball.
Right. Good. And I like that. I like the thing that you said about not wanting to create a suboptimal loop.
A suboptimal positive loop.
Ooh, because a suboptimal positive loop is actually going to cause the spurious behavior to happen, right? If there's a way that you can actually do a sequence of actions and generate profit where there really shouldn't have been in the environment, then it's distracting, right? The agent is going to end up doing things that you didn't want it to do. So we have to avoid creating these suboptimal positive loops. And so a natural idea from, I'm going to say physics, and you could tell I'm an expert in physics because, I understand Bellman's equation, Einstein's Bellman equation, and that is that the idea of potential functions. So what I'm going to do is define potential functions and then show how we can use them to do shaping without actually messing up the optimal policy.
I look forward to it.